Now I'm going to explain the principle of induction motor, right? So here you can see an induction motor consists of two different parts, that is stator and the rotor, right? So everywhere, every time, what we have to remember, for the stator we are going to give three-phase supply. So when we are going to give three-phase supply, then three-phase currents will be flowing inside the stator, so that a flux, three-phase rotating magnetic flux will be developed. So that flux will be flowing, right? That flux will be flowing in the air gap which was there in the induction machine, right? So now what is going to be happen, so I'm going to tell you, I'm going to give you the principle of induction motor here. So when a three-phase supply has been given to the stator, a rotating magnetic field is going to be flowing inside the air gap. So this rotating magnetic field is going to be interact with this rotor. See, you have to remember this rotor is in stationary position, and I have not shown you the rotor bars here. The rotor bars which are there in this rotor are completely short circuited. So whenever this rotating magnetic field is going to be interacting with this rotor, as the rotor bars are completely short circuited, so there will be a current flowing inside the rotor, right? So now so this is what the diagrammatical representation, simple representation. So this is what the B in the sense magnetic field, it is moving in this fashion, right? Moving in this fashion. Now this is the rotor conductor, so having a length L. So whenever the magnetic field is going to be interacted with the stationary conductor, what is going to be happening? A current is going to be moved. So according to Lorentz force law, so BIL, Lorentz force law, there induces some kind of force, that is BIL, which turns the rotor to be moving, right? Which turns the rotor to be moving. So this is what the principle of induction motor. So you have to remember, we are giving three-phase supply to the stator, and thereby there is a production of rotating magnetic field inside the air gap of the air gap. So that rotating magnetic field is going to be interacting with the rotor, which is completely stationary here, and as the rotor bars are as the coils in the rotor bars are completely short circuited, so there will be a current induced in the rotor, which in turn produces some force according to Lorentz force law, which in turn makes the rotor to move. Yes, thank you.